Now, we said that independent events are extremely important to us, and they are, because they are the basis for a model for a large number of situations. Now, unfortunately, it's not always true that we have independent events, and if we falsely assume that they are independent events, then we can have an error that can have horrendous effects, such as what happened to Sally Clark. Now, Sally Clark was a British solicitor who had a son at the end of 1996, and he died within a few months in December of 1996. She recovered from that event and had another son in November of 1997, and this one died in February of 1998. She was accused of and tried for murder of both kids, and she was found guilty. They were arguing that maybe this was sudden infant death syndrome, SIDS, and so the prosecution called an expert witness, a pediatrician, one by the name of Roy Meadow, who went off and did some probability calculations, and he came up with this calculation of his, that the chance that a particular family would have 2 SIDS deaths is 1 in 73 million. And he explained that 1 in 73 million, that's like going to the races and finding I think it was like an 80-to-1 horse and having that horse win 40 races in a row. So the 1 in 73 million is virtually impossible. And this carried the day. And as I said, they found her guilty, and she was imprisoned. Now, how did he get that 73 million? Well, here was Meadows' law. Meadows' law was that 1 cot death is a tragedy, 2 cot deaths, that's what the British call SIDS. 2 cot deaths is suspicious, and until the contrary is proved, 3 cot deaths is murder. Now, it's interesting because there is the CESDI report that studied 472,823 live births at roughly the same period in England between 93 and 96, and they found 363 deaths that were identified as SIDS or cot deaths. So using their empirical evidence, the chance of a cot death should be 1 divided by 1,300. So 1 per 1,300. Now, Meadow, for some reason, said, no, these are middle-class people, they're both solicitors, etc. He came up with this number, 8,543. So a SIDS death should have a probability of 8,543. 1 over that. And then he made the independence assumption. So he says, because of independence, the probability of 2 SIDS is this squared, and that's how he got his 1 in 73 million. Now, if we go back to this study, they had evidence of more than 1 SIDS death. They did it with a device called a case control study that Fran will be teaching you about shortly. But in the meantime, let's just say you compare 2 groups. And what they found was that in the 323 SIDS deaths that we just spoke about, there were 5 previous SIDS. In other words, 5 of those 323 had 2. So already you start wondering about the 1 in 73 million. But what they did is, so that's only 0.0155. But then what they did is they compared this to the control group, which was a group of 1288 control families, and found that the probability amongst that group is 0.00156. In other words, this is 10 times as likely. So if there is one SIDS death already in the family, it's 10 times as likely that there will be another one. So this casts a tremendous doubt on this assumption of independence in this particular case. And Voltaire, of course, had a saying for this one too. It is dangerous to be right when the government is wrong. And Sally Clark learned about that. She died shortly after they let her out of prison once the proper information was made available to the appeals court.